Hello everyone, so today I wanted to start the section on functions, and I want to start looking at the Rhino Geometry API with Python. It's really fantastic after so many years, in fact decade worth of uh, working with libraries and various programming tools. I still find that Rhino is really powerful, and Rhinoscript syntax is the one of the easiest and most elegant ways to access the functionality and develop novel geometric forms. Without further ado, we look at functions today. Functions are nothing but repeatable blocks of code. We will look at ways in which we can pass values between them so as to make our life easier, because we don't have to code as much. Alright, so first of all, because we want to start looking at geometry, I'm going to import. Notice the user interface is giving me all these options, and what I really want is Rhinoscript syntax. So I can just start typing, and you can see that it's highlighted for me. Once it's highlighted, I press the tab and it grabs that particular reserved keyword. So I'm going to import Rhinoscript syntax as rs. Now, so as soon as I type in rs, the compiler knows that I'm talking about Rhinoscript syntax. That's what this statement means. Get the library Rhinoscript syntax and call that rs. As soon as I type rs, it knows I'm going to use Rhinoscript syntax. Now, the way to use the library is to type in rs followed by a dot. So as soon as I put in the dot, then all these methods are available to us, and I'm going to start with the point. So geometry, typically we prefix with add, and I'm going to say point, rs.add point. Okay, once again it has already selected, and I'm just going to press tab. It will take care of the capitalization for me. So tab this, and as soon as I press the open bracket or open parenthesis, Rhino gives me help on function add point, and it says that add point y is none and z is none. So inside the the parenthesis, these are called parameters. You may also find that they are called arguments in other tutorials. So add point will have arguments or parameters, which is a point. And what is the point? Point is a point 3D. It is a list xyz. So that's what we are interested in, and we have seen in the basics that list how to declare or define lists. So I'm going to just define a list here. A as a list of say 0 0 0, which is basically the origin, right at the center point of the screen that you can see here. So this is the origin, and as soon as I add the point, it's going to place a point for me right at the origin. Let's combine this with the for loop. So let's say for I in range 0 to 10, I don't have to put the comma 1 here, which if I don't use this comma 1, that means it's by default Python knows that it's going to increment the value by 1. And notice that I put the colon, and I haven't hit return because I need to have the indent. So now it's going to add the point a, and it's going to add it 10 times because I'm not changing a here. Okay, so maybe we can directly have a here, and it's at the x coordinate. So the first index or 0th index is the x coordinate. I just place I. So now the point is going to go in the x axis, and it's going to iterate by 1 each time. Okay, and it's going to do 10 of them, starting with 0, okay, and excluding the 10th value. So it's added the 10 points. Now, okay, let's do a nested for loop for j in range 0 to let's say 5. So I just select both of them and press tab to get the right indent. So now we have two variables inside of the list. One is I, the second one is j. So as soon as it puts in I, the value I becomes 0, and the first iteration at line 5 it's 0, and it goes to j. So a becomes a, so the first value will be 0, 0, 0. Then in the second iteration, it's not going to go to I or the outer loop. It's going to the inner loop which is line 6, and the value of j will increment each time. So it will be 0, 1, 0, and then the next will be 0, 2, 0, and so on. I'm going to remove this comment. Okay, let me keep the comment, fine. Okay, so it's going to do 5 in the y-axis, so it will plot this point, then do 5, then come back and plot the next point on the x-axis, do 5 more on the y-axis, and so on. So I'll delete the previous points, and I'm going to run the code, and notice the difference. There are 5 points added on the y-axis, whereas 10 on the x-axis. So we can just extrapolate this logic and say x in k in range 0 to, I'm going to do even fewer iterations here, 0 to 3. So even though Rhino is really excellent, the problem with Rhino and Rhino Python is that it's super slow. So the performance is not as great as some of the other frameworks, and that's to be expected. So if I do ijk, then it will also plot 3 in the z-axis. Okay, so I'm going to erase everything and run the code. Okay, so we have a 3-dimensional grid. So we were going to do what is the topic today, functions, right? So now let's assume that we want to, I just want to show the function first. Later on we can see ways in which it can be more complex. So let's say we add a point, so let's say def point, and then we take in 3 values, so x, y, and z, and we just plot this here. And at this point now, so now we have, this is called a function. So line 3 to line 6 is one function. It's denoted by the keyword def. I think that stands for define. The function is called point, and it takes in 3 parameters or arguments, x, y, and z. So if we plot x, y, and z here, sorry, this is, now let's change that. So if we plot x, y, and z there, then we can say, then when we are plotting, when we are going through the nested for loops, we can say point I, comma j, comma k. Here I will map to x, j maps to y, and k maps to z. So a is actually the same ijk, it's just that I've renamed the variables to show that this is exactly the same thing. Okay, I'm going to run this code now. So what is the real purpose of this? Right, to see this in action, really what we can do is let's say def loop, let's say p and c. Okay, and then I have my for loops also inside a function. Okay, so my for loops are in a function, and this point is actually being plotted also in a separate function. And now if I run the code, really nothing will happen, because this is inside of a function, right? So when Python is compiling this code, it goes through, it imports this Rhino syntax, then it knows that there is a function, and it sees the function, it compiles it, but it doesn't execute the function. So to execute the loop function, for instance, we can say that loop ABC. So we can say 1, 2, 3, and here instead of 10, 5, and 3, we mark, we replace the constant values by variables. So now we have parameterized this for loop entirely, and we are calling just this loop, which goes, we are calling the loop function here with values 1, 2, and 3. That means it's going to plot, execute the outer x yeah, it's going to execute the x only once, then it's going to do twice for y, so x is 1, twice for y, and then it's going to do 3 more for z. Okay, yeah, so it's done x1, y has 2, and z has 3. If we go back to the previous one, we can simply do this. So these were the previous values, and if we execute them, we can see that it's plotted. We've got back the same three-dimensional loop. But now suppose you had a more complex program and you really didn't want to get into the mechanics of this, of how the looping work, then we can just very simply do this. Now let's say that you want to have, instead of the point, you want to put a circle, right? So let's say point is equal to false. Okay, so I'll just mark p is equal to false. That means don't do a point, do a circle. It's that. Okay, and then if I put in p here, that means we have to update our loop there. Actually, we don't need this dialog box. I'm going to reduce it. Okay, so now this value of p goes to the loop function, and from there I want to go to the point function, and so here also I get p. And now if I say that if p is equal to true, then plot the point, else plot a circle, let's say. So rs.add circle a and say 0.25. Okay, let's do a circle. Okay, so p is going to be false, so we'll do a circle. So we have the circle. It's doing 10 in x, 5 in y, and 3 on the z axis, right? So we have this. Okay, so it's interesting. We can also do something more, which is that, say, let's import random. So random is a Python module. It's not necessarily Rhino Python. So import Python, and let's say we want to return the circles for this particular array. Alright, so what we can do is, say for example, let's say circle is equal to an array. It's going to be a list, okay, and when it is a circle, it will return the circle. Let's say c, where c is equal to this. Okay, so now we make a variable c, which is either the point or it is the circle. Okay, so it's going to return that, or else you can do return c there like this, and we say that point c is equal to this. So now we have access to this circle. So it's going to create this loop. So it's going to be able to grab all these circles created under this particular loop, under the innermost loop. We are going to have access to this, and we are going to create a list which will hold this. So circle dot and c. Now if I loft this, let's loft this surface. rs dot loft, add loft surface, loft srf, and this circle here. Okay, so we are going to be able to get cylinders right here. Okay, also I want to reduce the number of x's and y's and actually increase the z. So it gave me an error. Okay, so it's giving me, so if I run the code, it's giving me an error saying that integer and argument expected got quit. So which means I believe the error is on line 9, and here we have range C. Now C has actually taken the value of this function, right? But we are also using C to declare or increment the loop, so evaluate the loop. So if we change this variable to say X, then it should work perfectly, and it does. So we know that we've got this kind of cylinders based on the grid that we created. And to make things interesting, what we can do is, so now we have imported random. So let's say, suppose that we change the radius of this of each of the circles, then it will create some random shapes. 0.25. So I'm just going to do a simple random function here, 0. Okay, let's see how this behaves. Okay, so very easily we have created all these geometries. These are all surfaces, and they are slightly random, and it's looking interesting collection of surfaces that we have here. So I just want to show how we got this. So we defined two functions. The first function is a loop function which takes in 4 arguments or parameters. These are for the 3 loops that we have, and the loops are nested inside. So the first loop, or the outermost loop, starts with I, and it's going to plot objects along the x-axis. The second one is the y, which plots these along the y-axis, and then we have the z-axis. Okay, so I, j, k, x, y, z, and they take the values a, b, c, which we defined outside on line 25. Finally, we have p, where p is either going to plot the point or the circle. We say that p is equal to false, so it's going to plot the circle, right? So once we have this 3 loops, then we generate the circle by calling it a point, by calling this function pt. And Python is really flexible here, because if you just look at this function def pt on line 14, then actually in one condition we don't return a value, and in the other condition we return a value. There's a lot of scope for error, but it also shows that for doing this simple things where we know exactly what's happening, we can have this kind of a flexibility. So what we are doing here is, we have the first loop, so we go through all the loops, all the 3 loops in XYZ. We call the point function, and from the point function we actually either plot a point or we plot a circle, and the circle has parameters, which is the origin or the center of the circle, and then we have the radius. To define the radius, we're using a random function, and then we return the circle. So when we return the circle, we collect all the circles on the z-axis as in a list, and then we add a loft surface to the circles. So that gives us these nice shapely cylinders. Okay, thank you. We'll continue next time.